In this tutorial, we're going to talk about how to add resistors in a parallel circuit. So if we start with a parallel circuit, we're going to have a power supply. We are going to have a bunch of resistors in parallel. So we've got one. Actually, we'll keep it at two, but just keep in mind that what I'm doing could apply quite easily to more than two resistors. Now we're going to call these resistors R1 and R2. We've got a current that's flowing around our circuit, positive, negative terminal. Conventional current flows around from positive to negative. And we're also going to add some voltmeters to the circuit as well. So we've got a voltmeter here across the supply, that's VT, the total voltage in the circuit. We've got a voltmeter V1 across resistor 1. We've got a voltmeter V2 across resistor 2. Now if you remember, we know that in a parallel circuit that the voltage is the same everywhere in the circuit. So Vt equals V1 equals V2, it is the same everywhere. We also know that the current is going to be shared. So for example, if we have this current here, call that I total. So I total, and coming back into the other side, I total. So everywhere in this part of the circuit, we've got the total current. And then we know that in this part of the circuit, in the blue, and this part of the circuit in the green, the current is going to split. So we're going to call this current here I1, and that current there I2. We know therefore that I total is I1 plus I2. So there's our two starting points. The voltage is the same everywhere across parallel components, and the total current is shared, equaling current 1, I1 plus I2. Now, if we look at each of the voltmeters one by one, Vt would be equal to I total R total, because of V equals IR, so Ohm's law. We know that V1 would be I1 times R1, and we know that V2 would be I2 times R2. Now just a quick bit of rearranging, it'll become clear later why. If we write it in terms of current for each one, the current total would be Vt divided by RT. The current 1 would be V1 divided by R1, and the current 2 would be V2 divided by R2. We just rearrange those formulas. And I'm just going to circle these so we can refer back to them later, because we know that I total is I1 plus I2. That means that this guy right here must be equal to these ones added together. So looking at that means that I total, which is Vt over R1, must be equal to I1, which is V1 over R1, plus I2, which is V2 over R2. So that comes from that formula there. If you remember, the voltage is the same everywhere across parallel components. So, sorry, that should be total. V over R total must be equal to V over R1 plus V over R2. Now, after all of that, we can see that V is common to all of them, which leaves us with a not so simple equation, but anyway, 1 over RT is 1 over R1 plus 1 over R2. And that is the formula that you would use when determining the total resistance is in a parallel circuit. Now this formula is reasonably simple to use, and I guess the foolproof way of using the formula is to use solver, and that way you don't have to worry about getting yourself into a muddle in terms of the algebra. So let's imagine that our resistors are as follows. So we're told that R1 is equal to 2 ohms, R2 is 3 ohms, and we asked to work out what the total resistance is, so what is RT. Now, if it was a series circuit, it'd be easy. We could just add them up. But in a parallel circuit, we need to use the formula that we've just proved below. By the way, you don't have to know that formula off by heart. It's given to you in the exam paper, so don't worry about all the complicated mathematics if you don't want to. So to work it all out, we know that 1 over RT must be 1 over R1 plus 1 over R2. That means that 1 over RT will be 1 over 2, which is R1, plus 1 over 3, which is R3. Now, this is not such a hard one, so you could probably do it in your head or do it by hand, but I want to show you how to use Solver to solve a problem like this. Essentially what we do is we plug it into the calculator as it is there, but we replace the RT with an X. So what you want to do is bring up your calculator and just move that to the side so we can all see it. And what you're going to do is go into the menu and run into equation. And we want to choose solver. Okay, put it in as it is. So 1, I'm going to use the fraction button, so 1 over, and I'm going to go X for the RT. And then we're going to go the equal sign. Okay, so is equal to 1, the fraction button, 2 plus, oops, I've done 2 pluses there, plus 1 over 3. We hit the execute button and we hit solve F6. And you can see the calculator has determined that the total resistance in the circuit is 1.2. So R total equals 1.2 ohms. And that is all there is to it. Using Solver takes away all of the complicated algebra, and as long as you're careful when entering the numbers, it is very straightforward.